everyone. Apologies for not being able to attend there in person, but then again, I'm not that good looking, so you didn't miss much. And as long as you can hear me and see the presentation, I think that would be great. So today I'm going to talk about LLM API servers, or as they are also known as AI gateways. And I'm going to divide this session into three parts. We're going to start talking about API gateways, which are also known as the ancestors of AI gateways, and they share. We'll start with that and get on the same page. Then a little bit about the AI gateways. Why do we need them? And what can they do for us? And then see some examples of products and libraries that you can choose to use if I manage to convince you that this is necessary. Of course, but a little bit about me. So my name is Erez. I've been around for quite some time, lately doing architecture, cloud architecture, enterprise architecture, and a lot of AI research for the software development lifecycle as a aid for developers and for DevOps. By the way, all the visuals for this presentation was made by an AI product called Gamma. So I think AI is going to be a big part in this session, and I think in every conference from now on, it's going to be hard to avoid these letters. So let's start a little bit about API gateways. And I can't see you, so I don't know how old are you, but I was there at the time, believe it or not, that there weren't any microservices, and all of the application was wrapped up in one big library or executable and ran on some large servers. And that was fine up to a point, especially after the internet came in, and application had to deal with lots of users and lots of requests, and the scaling of an application and the release of application became hard and tedious, and also agile methodologies came in to help. And one of the solutions to handle that was the microservices architecture. And I guess you probably know it, since this is the go-to architecture nowadays, even if it's an overkill sometimes. But usually the approach is breaking a large application into smaller services where you can deploy independently, develop independently, debug independently without interfering, which is great in many cases. But as you know, nothing is perfect, and you have pros and cons for everything. And when you start to accumulate microservices in your application, and you're starting to have 10, 20, 50 microservices, it's getting hard to manage them, right? To administer, to track everything, and even to approach them, right? Think about an application with, let's say, 50 microservices, and sometimes you have a few instances of every microservice. How do you approach them? You can't expect a client to keep track of even the URLs and the addresses of every microservice that there is, and think about changes if you add a microservice or eliminate one. This is too much to expect. So this is where gateways came along, and basically, as the name suggests, were the entry point, the gateway for every other service inside the application. So the gateway knew all the details of the services inside, and could help us with a few things. And I'm naming them because even when we talk about AI gateway, these are still relevant, right? Even if the service that we're talking about is an AI service, it approaches some LLM model and perform a queries, submit a prompt to the model, then it is still a service, and we still have to reach it and authenticate and some other stuff. So this is the common stuff. So an API gateway can do the basic stuff of routing, right? Where is the service located, and maybe even some load balancing if we have several instances, for example. We don't want every service to do the same authentication and manage that in every service, so we can do that on the API gateway. And same for rate limiting, right? If our service is public, this can be a concern. So again, we can do that in every service and manage it in every service, but it's pointless, right? It's better to do it in one place. And we can even do higher level operations like API composition. For example, our API gateway can call API A, take the result and pass it to API B, examine its result, and then decide whether to send it to API C or API D. So it can have some logic. It can do stuff as protocol translations from JSON to protocol buffers or any other protocols around. An API gateway can give you some analytics and monitoring, and this can be technical. For example, how many requests did we get? What's the average response time? And alert accordingly. And it can give you some business information. It is less common, but when you think of it, the APIs can tell you a lot about your business, right? Which APIs are being called more and from which geography, for example, or which products are being read. So usually companies do that from the data side, right? From the database and do some analytics there. But the raw data is not always aligned one-to-one with the business. And the APIs are more business-oriented, or at least they should be. So they can give you business insights more easily. And again, this is all is true for AI services as well. So we have a few things that an API gateway can give us. And there are a lot of products you can use. These products can be run on-premise, or can be run as a service. I'm not talking about the cloud provider. I'll reach that in a second. But as you can see, beside all the cloud providers, there are some other companies that can give you such products. They are very common nowadays. And if we take a look on Kong, for example, it has an open source version that you can use and a paid version. Of course, they're always willing to get paid. So we can take a look at it. And this is the page of the services. This is one of the services I've defined with the actual service behind the API gateway. So we can take a look at the service. There are a few definitions. The actual details does not matter, but you can see some timeouts and some routes you can define, and we can even make a call here to the service, and this is the response from HTTP bin, which is just like an echo response, and we went through the API gateway. We can check that and go through the actual service behind, and see something similar from the service behind, which is great. In this case, I know what the service is. And as you can see, there are a lot of things you can do with this API gateway. Lots of plugins you can add. You can add security. You can add all the stuff that we talked about and connect it to other services as well. And if we let's check out, cache. There's also caching you can add, for just as one example. And so as you can see, lots of plugins, lots of stuff you can use and get all the functionality, which is great, just as an example. And of course, you can use the cloud provider's API gateway, which makes sense if you don't run things on-prem. Sometimes you have to if you're in government or banking or any enterprise that likes to keep things on-prem, but many startups are starting in the cloud. So using an API gateway in the cloud makes a lot of sense, saves you all the maintenance and installation and tracking and everything. And so let's take AWS gateway for example, which is a very common service. It has a few advantages over other API gateways. It's very easy, and I'll show you that in a second. And it can connect you to security features inside AWS. For example, if you're working with AWS Cognito, with other security services, it can connect seamlessly. And also to other AWS services such as Lambda or SQS, a queue, or a lot of other services. The connection is being done directly in the definition, so you don't have to put in a lot of effort. And it's scalable, of course, probably more than you can handle on-prem, and easily connected to all the monitoring and logging applications inside AWS. So you can get a lot of benefits. So let's let's see it here, for example. So I'm on some AWS account. I'm starting an HTTP API gateway. So I'll add an HTTP integration. It's not directly connected to a Lambda. Let me just grab the path from here because I'm too lazy to type. Let's call it test, for example. And this is where my service, the root of my API gateway service will go here. Pretty easy, and I can define a lot of this. And of course, I don't have to do it through the console. Usually, I'll do it through code using CDK or Terraform or any other auto method which I can control and replicate easily. And basically, that's it, right? I have this API gateway up and running now in AWS, and I can test it easily from here and get the same result from the backend service in HTTP bin. Right, fairly easy. Of course, you can configure all the stuff that I've talked about before, but you get some pretty decent defaults, and you can exploit these advantages in AWS. So these were some examples of API gateways and things that they can do, but we're not here to talk about API gateways. We're here to talk about AI, right? Like I said, AI is everywhere right now, and I can safely bet that in every session in the conference you'll hear the letters AI, in context, out of context, but it's everywhere, and for a good reason. I think the world's going to change forever. Even software development or lots of other professions and business processes not going to be the same, and probably your company will want to use some models, right? They can be third-party models like ChatGPT or Claude or any other model, and they can be models that you developed in-house, and I'll talk about enrichment in a second. But I think almost any software company is going to rely on some AI models or LLMs one way or the other, either to develop software or to give some business service that's based on AI. And these models, usually you work with these models in two phases: the training and actually serving requests. So if you want to prepare a model, don't know if you've done it yet or planning to do so. Like I said, you're probably going to do that in the near future if you haven't yet. There are a few steps that usually involve. First of all, you need lots of data. And again, if you're not training a model from scratch, you just want to fine tune a model to your own company's information, you're still going to need data, right? And this is important because the data has to be relevant if you want to use it in a RAG or some enrichment of the model. So you have to work on that as well. Usually, data sciences, the scientists are doing that, or it can be developers. Nowadays, there are lots of tools that can help you do that. You don't have to have a PhD in data science to actually collect and clean and prepare the data. Things are easier now, but once you have the data, you have to train the model, either fine tune it or train it from scratch, which takes a lot of effort and a lot of iterations and involves many calculation. And your work never ends because in real life things are changing. So occasionally you have to fine tune the model again. So there is some work involved if you want to prepare or fine tune a model, but usually I think that many companies, including my own, not building an LLM model from scratch because of the effort involved. Although cloud providers are letting you fine tune it fairly easy by uploading your own data, but in many cases you don't want to do even that. For example, if you want to do some customer service or even code development or any task that an LLM model can do fairly well on its own and just missing your own information, then you won't fine tune it. You'll enrich it in some way. The easiest way is to do some prompt engineering, meaning adding some guidance or some proprietary data in the prompt. It can be fixed information, or you can use RAG, meaning selecting relevant information from somewhere else, usually a vector database that can store your own company data in a semantic vector space, meaning you use some embedding model to get the vector representation of your company data. And later on, while you're creating a query, you'll start by querying the vector database for semantically close chunks of information that you've stored there, which are your own proprietary data, and then add it to the prompt. So basically helping the model with some data that's probably going to help it answer the question with your own information. And all of this stuff can be done using some AI service that you've deployed and want to access it via API gateway or an AI gateway. But this is a general process. And in production, things are a little bit different because you don't train the model and you have less iteration. But if you're lucky, you'll have lots of users to your service that's using a model. So you have to think about scaling and load balancing. And again, you're continuously improving your model if you want to keep it up to date, or at least continually enriching your vector database with the recent company data. In any case, you'll have to maintain that. So keep that in mind before you enter such a process. And if you don't have an AI gateway, you have to deal with a few things yourself. First of all, let's talk about multiple models, right? Multi-modality and multi-models are two different things. Modality, when you say that, you mean a different kind of models based on text or sound or image generation, which can also be a use case. But here I'm talking about multi-model, meaning few models that you want to work with. And there can be different reasons for that. And I think the industry is converging into using a few models. But first of all, I think that you have different advantages in every model. Some models are more suitable for code generations, and some are better for other use cases. So you want to give the best answers you can. And due to the cost, if you can do with the smaller models, you have in GPT-4, you have the mini models, or even run some open source model on-prem, and only if it doesn't give you the good enough result, then you can switch to an external third-party model that you pay for, right? Because these models can be costly, especially the largest one, that supposedly giving you the best results, but they cost more. And think about millions of requests. If you supply some business service with lots of users, then you'll have a lot of requests, and these things accumulate and can be the difference between a profitable company that will last and expand, and a losing company that will close eventually. So if you're in a startup or in a department that wants to expose some service based on AI models, you'll have to think about the cost. So you'll have multiple models, and scalability can be an issue, right? Same as any other service. Sometimes you have to scale and do some load balancing. And without some gateway, it can be an issue for you to handle. All the monitoring and the security, again, same things as with an API. Of course, the different models and the costs are unique to AI, but other stuff is not. So there are some problems, and we can, when we see those problems and we have the experience with the API gateways, we can start to define what we want to achieve and get from the perfect AI gateway. Of course, not everything is relevant for every company, especially at the beginning, but I think we can define some points that are common. For example, we want one endpoint, right? We don't want our clients to know all the services and the models that we use, and our own considerations when do we choose to use which model. So we want to have one endpoint, same as with the API gateway, but maybe for different reasons. We want to track the cost and the usage, like I said, and with models we have quotas, right? It's a bit different than some other service that we run on-prem, and we don't track the usage usually, and because we don't have quotas for it, maybe just for scalability reasons, but not for cost reasons. And here we do have that, especially if we use some third-party models some of the time. So it's important, and sometimes we don't want everyone to be able to access any model, right? Because of cost or for any other reason. We'll have to do some security / permission management, and it's not just the access. In this case, especially with third-party models, we have to think about data going out, right? Although usually if you pay the ChatGPT or Claude, they promise you that they won't use your data for training, but can you believe them? And sometimes there are errors, and accidentally your data can be used. So this might be an issue, and one of the solutions to enable you to actually use them, even though you have confidential information, is doing anonymization, right? Take some secret items of information. It can be IDs, it can be credit card numbers, it can be any data that you don't want to expose, and you can obfuscate it or anonymize it, change it, omit it, do whatever your security officer asks you to do in order to make your data confidential. And this can be done from the AI gateway as well, right? Because the prompt is a text. So you can control that fairly easy, even with the help of some inner model, right? You don't have to do everything in a deterministic way in code. You can use models for some of the tasks here as well. And of course, all the operational stuff, right? The logging, the monitoring, the caching, all the retries, all the stuff that we want our gateway to do. And again, in this aspect, not much difference between an API gateway and an AI gateway. So I think that by now I hope I convinced you that there is a good reason to not just use an API gateway for that, but to add some other features and call it an AI gateway. So how can we do it? How can we implement such a thing? Here in this slide, I've described gradual growth of such a system. If you want to build it on our own or use some other tools as building blocks for this gateway, we can start with a simple SDK, right? We'll see one in a few minutes, but there are few libraries that help you access AI models and expose unified APIs and can help you with the RAG process. I'll talk a little bit about Spring AI in a sec. But an SDK is usually not enough because it lacks some other features that you need, especially around security. So you probably want to add some key management systems. If you have a few models or a few types of users, then the tokens that you use to access these models should be managed somehow, right? And alongside there comes the quota and the payment for this stuff. And later on, you don't want everyone to access these models uncontrolled, so you're probably going to add some authentication mechanism. And eventually for tracking, you can add some log or tracing ability. It can be built in if you're running in the cloud. It can be some library that you add in-house, like Zipkin or any other logging and tracing library. So picking stuff from here and there, you can build some functional complex that will actually serve you as the AI gateway. But you might have noticed that we're missing the API gateway part, and so we can just add it, right? So maybe it's even better to go the other way around, starting with an API gateway that you probably already have, and then add those AI-specific features as a library or some other gateway. And even if you're running some model development in-house, you're probably going to integrate it with your MLOps platforms, right? If you have a new version of a model, you want to deploy it and make it available to users via this AI gateway. So everything should integrate nicely. And a good example, I don't know if you guys are working in Java or in a different language, you can use two, let's say, libraries or frameworks under Spring, which are the Spring Gateway and the Spring AI. And just a few words about Spring AI, if you're not familiar with it. It's very similar to LangChain in Python. It's some kind of framework that can abstract the inner implementation of the AI development lifecycle. For example, we talked about storing stuff in a vector database and then using it to extract relevant information from the prompt, and then you approach the model, and maybe later some post-processing, like anonymization or any other post-processing you might want to do. And Spring lets you do that in a, let's say, vendor-independent way, same as LangChain. And of course, you can plug in different vector databases, different models, etc., via configuration and in a transparent way for the developer or the user. So it's a good base product to act as an AI gateway, and its advantage, again, it's suitable if you write Java and use Spring anyway, and you have the development capabilities to work with it. It's very flexible, right? It gives you many things out of the box, and the stuff that you don't get out of the box, you can add and write or use other libraries. So if you choose to take this path of writing your own code, this can be a good base. And then later you can combine the two. Spring has the Spring Cloud Gateway, for example, in case you don't use another gateway, or maybe you're already using the Spring Gateway, and it's a perfectly good gateway with all the features. And again, you can write code to add filters that do whatever you want. So such a path will be a request reaching the Spring Gateway. It can differentiate between AI-related services and not, according to the path, for example, or some header in the HTTP request, or however you want to differentiate. And if it's not an AI request, it can go to the relevant service that's running on this application. In case of an AI-related request, we can pass it on to Spring AI that will do the actual RAG enrichment and choosing the model and every other processing that we discussed earlier, and of course returning the request. So this is something you can build fairly easy, of course, if you want to write code. So the process, and this is, I'll go through the phases, but this is not specially related to Spring. It's true to any mechanism below. So we get the request. We should do some authentication and maybe pre-processing for checking the data is safe for us and the question is valid. We might want to reject some requests based on the context, on the content, sorry. We'll do then the actual routing. Which service are we going to send it to? And maybe then protect the data from coming out, the anonymization part that we talked about. Hallucination is starting to be less of a problem these days, where the models are getting better and better, but it might still be an issue. So you can do some validation with using another model to cross-reference the answers, or maybe do some validity checks on your own in some other way. So maybe it's a good idea to do that if you're sending some results to external users. Then you can do some post-processing such as caching, which can be very useful because, like I've mentioned, requests can be costly. And then you can send the actual request, for example, via streaming. Yes, remember that you're not limited to one request. Sometimes we think about our own console-based interaction with a model, but let's say you're a company that wants to create personal invoice generation, right? And for every invoice that you send to a customer, you might want to add some personal words created by AI. So you can send all the requests and the information of the invoice to the service, and then it can be done concurrently, and responses or invoices information can be streamed back to you. So it doesn't have to be just one request. So if we have the path here, we can start talking about some tools other than Spring AI. You have some pre-made libraries and products. So for example, vLLM, which is kind of a basic but very useful library to serve models, AI models. It has all these capabilities I've written here, and you can run it. I've just run it on my machine using Docker, and we can see it here. For example, it has a Swagger OpenAI interface, and I've prepared this request, and it comes with, in this case, this is like an open source model that we can run, and I hope you can see that. Let me make it a little bit larger. So if we run the request, it's going to take a second, as I don't have such a strong laptop, but we get an answer asked about San Francisco, and the text completion tells me that it's a great place to live, which is great. And by the way, everything is running on my own lousy laptop. And of course, in real life, you'll use some other larger server, but you can easily serve it through an API, right? Serve the model via API using vLLM. The next phase is OpenLLM, right? Similar, and it lets you do more stuff, right? It can support multi-models, and the API it exposes is compatible with OpenAI, which is useful because you can use one client and uh, access many models behind the screen. It can integrate with some MLOps tools, uh, which is useful if you're running or building your own models. Of course, it doesn't have to be LLM; it can be any model. And under the hood, it can use vLLM that we just seen to do the actual serving uh, of the query. So this is kind of the next step if you want to run things yourself. Uh, Here's a little comparison. Basically, if you want to take it to the next level and scale things up, you'd go with OpenLLM, which is more complicated to configure, of course, but gives you a lot of other capabilities. And if you don't want to run your own libraries and host them in a Docker, you can use some other pre-made products. MLflow, if you heard about it, it's a very common, like open source, partly MLOps tool, right? You can use it to run your workflow from testing and training into production. And they have an experimental AI gateway that makes a lot of promises about the unified experience that we wanted from an AI gateway, and security features, of course, integrating with all of the other services. So they have a lot of promises, but this is still experimental and less useful now, I think. But things are changing every day, so if you like or using MLflow anyhow, so you can check it occasionally. My favorite is actually the Portkey AI Gateway, which is, I think, the most complete AI Gateway product. Again, we started from the other side of building our own with Spring, and this is the other end of using a product, and I like it. I'm not related to Portkey in any way, not working from them, not getting anything from them. I just liked the product, and they have a nice UI. I can show it to you. And this is the free tier. I didn't pay them anything, and I ran some queries so I can see some statistics, and there's some logs. You can see that they let you do some prompt engineering, and of course saving all the keys, and you can use various configurations to add things like caching and retry. They have a nice thing that's called semantic caching, meaning they don't just cache the exact query you send them. They can give you the same result for similar queries, but you have to pay for that. Retries and timeouts, you can pretty much configure everything. And here I've created a request. Let me show you the code from the beginning. And this is I'm using the regular OpenAI client, just mentioning that the URL I'm working with is the Portkey URL. I'm not sending that to OpenAI actually. This is nice. So here I'm passing in the header the Portkey API key for them to identify me, and the name of the configuration. I've just showed you. This should be the same one. Yes, it is. So I'm going to use this configuration, and again for different requests and clients, etc. I can use different configurations. This is dynamic, and affect the caching, the retries, the models I should use, etc. Everything is pretty much configurable, and then I'm sending this request for GPT-4. In this case, I'm setting the model, asking about the president, and In this case, the AI gateway is acting as a simple API, except that the caching, not letting it choose the model for me. So I get that Joe Biden is still the president. Still got a couple of weeks until he changes, and I'm supposed to see that in a log. Actually, this is the first request, and actually, I got a cache hit, which is great, and the number of tokens, so I can track the cost easily. It actually give me the amount of cents that they're going to charge me for it. And let's try and avoid the cache. I don't think I've asked him this question. Yes, and it's still Macron. This is right, and oops, it's added here, and I don't have a cache hit for this question. So this is nice. Okay, we are running out of time, so let me try and sum up what we've talked about. Right? I try to convince you that an AI gateway is a useful mechanism that can help you if you want to serve AI models, LLMs or other models, and that it has some unique features that are not part of the regular, so to speak, API gateway. So I think it has a right to live on its own. I suggested the scalable approach, right? Don't jump to a full-scale product. Probably you're going to start with one model that you serve and a few users and a few services and grow with that. So you can do that. And I've showed you a number of open source solutions like vLLM or using Spring if you want to write code, and up to a full blown product like Portkey. So at the end, you'll have to analyze and decide what's working best for you. So thank you, everyone.